Okay, one more. We're going to take a look at the function f of x equals x squared minus 6x plus 12. First question. Please give me the equation of the vertical asymptotes. Maybe I shouldn't have said asymptotes. There's just one here. There's a vertical asymptote at x equals 4. Next, will there be a horizontal asymptote or will there be a slant asymptote? Because the degree of the numerator is 1 more than the degree of the denominator, there is a slant asymptote. We're going to find it by doing some division. I'm going to go divide x minus 4 into x squared minus 6x plus 12. Go do the division, and then please tell me the equation of the slant asymptote. Okay, x squared divided by x gives me x. I'll put that over there. X times x minus 4, x squared minus 4x. Parentheses around that, and I'm going to subtract. Negative 6x minus negative 4 gives me negative 2x. Bring down the 12. I'm going to divide. Negative 2x divided by x is negative 2. Okay. Negative 2x plus 8. Parentheses, and I'm going to subtract. Those are gone. I'm left with a 4, so plus 4 over x minus 4. The slant asymptote is the non-remainder here, so my slant asymptote needs to be y equals x minus 2. Slanted line, my graph's going to get really close to. I'd like to see if you can go do your first derivative. Find the first derivative, and then press continue. Okay, low, x minus 4, d high, 2x minus 6, minus high, x squared minus 6x plus 12, d low is times 1, that's nice. Draw the line square below over x minus 4 squared. Okay. We need to distribute the x minus 4 times 2x minus 6, that's 2x squared minus 6x minus 8x plus 24 minus, make sure you're being good about distributing the negative. I've noticed some of you have some difficulty with that. X squared plus 6x minus 12 over x minus 4 in parentheses squared. Okay, so this is x squared minus 8x plus 12 over x minus 4 squared. I'd like you to go factor the numerator, find your critical values, and test your regions. Let's see, x minus 6, x minus 2 over x minus 4 squared. I've got critical values. I'll do my work over here. I've got critical values at x equals 2 and 6 from the numerator and 4 from the denominator. So let's see. The denominator's not going to matter because it's always positive. Plug in 7, positive. Positive, that's positive. Plug in 5, negative. Times a positive, that's negative. Plug in 3, negative. Times a positive gives me a negative. Plug in 0, negative. Times a negative gives me a positive. I have got a relative max at 2 comma something, and a relative min at 6 comma something. What are the coordinates of the relative max? Well, that's f of 2 That means I've got to do 2 squared is 4, minus 12 plus 12, oh that's nice, over 2 minus 4, let's see, 4 over negative 2, I'm getting negative 2 for that coordinate. What are the coordinates of the relative min? (36) minus 36 plus 12 over 6 minus 4. 12 over 2, that is 6. Okay, my relative max is lower than my relative min, but we already saw one of those in the packet of just graphical examples we started with for today. So we're going to have a similar situation with that. Next, you need to calculate your second derivative. I think the best way to do it is to use this version of the first derivative. And then there's going to be a lot of GCF work and cleaning things up and all that. If you can do this properly, the second derivative is going to end up being really, really nice. See how far you can get with finding the second derivative. And when you're either done or you just give up, push continue. Low, x minus 4 squared. D high, 2x minus 8. Minus high, x squared minus 8x plus 12. D low is times 2x minus 4 to the first times 1. Draw the line square below. X minus 4 squared gives me x minus 4 to the fourth. I'm going to take out an x minus 4 because I've got an x minus 4 here and an x minus 4 over there. There could be other things I could do, but this will be good enough. So I'm taking out an x minus 4. I'm going to be left with x minus 4 times 2x minus 8. I really should have skipped a line in my notes. Whatever, I'll do that next time. Minus 2 times x squared minus 8x plus 12 all over x minus 4 to the fourth. Okay, the whole point of that was so I could make an x minus 4 cancel. My denominator is going to be x minus 4 to the third. Up top, I need to distribute FOIL whatever over there. So x squared minus 8x plus 32. I'm going to distribute a negative 2 to those pieces, so minus 2x squared plus 16x minus 24. And f double prime of x is going to equal, the x squareds cancel, all the x's cancel. 32 minus 24, that's just 8 over x minus 4 cubed. Take a moment and go do your second derivative number line. Test for points of inflection and all that stuff. I'll make the video pause. Okay, plug in 5. 5 minus 4 is 1, cubed is 1, 8 over that, positive. Plug in 3. 3 minus 4 is negative 1. Cubed is negative 1. 8 over that, negative. So point of inflection at 4 comma... Oh, wait a minute. Go back to the original. We've got a vertical asymptote at x equals 4. So nope, concavity is changing there, but no actual point of inflection. See if you can put all this together and sketch the graph. Okay, so I'm going to draw some axes over here. I need to go a little higher. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Sorry, I'm not sure why you have to hear me counting. Let's see, I've got an F number line, an F prime number line and f double prime number line. F prime, f double prime. That's one on the screen. Oh, good. Okay, vertical asymptote at x equals 4. Slant asymptote at y equals x minus 2. So start at negative 2, slope of 1. Should be kind of like that. Okay, max 2 comma negative 2, so about there. Min is 6, comma 6, let's see, 4, 5, 6, about there. Getting those number lines down here, I've got 2, 4, 6, positive, negative, negative, positive. Bracket 4, negative, concave down, positive, concave up. I'm going to do my F number line of putting all this stuff together. Concave down increasing is what I'm doing there. Concave down decreasing over there. Concave up decreasing. Concave up increasing. I'm going to start by my asymptote, and I'm going to do one of these. Really should be going up to that. Curve around and come down to get one of those. I'm going to come down like this, concave up decreasing, then concave up increasing, and I'm going to get close to that asymptote. Probably should have put the graph in a better place so it didn't cross that work. But there we go. These are hard, and the work is messy. With the homework tonight, I'm going to post my solutions right away. So as you go to do the homework, use my solutions to help you out if you get stuck. What I don't want you doing is do problem 1, get stuck on like the second or third line and not be able to really get anywhere else with that. That's just a waste of your time. So please do use my work. Use it responsibly, of course. Don't just copy my work, but actually use that to help you out and see what we can do. But this is tough and it's messy.